can see a question here that from Engineer Olawuyi. He said, I need clarification on the difference between features and samples. Okay. Yeah. Features and the features. Yeah, thank you very much for that question. So clarify. When we talk of features, these are the characteristics of the samples that you want to use in your application. Let's say, for example, we want to build a machine learning model that can detect if somebody is suffering from a particular disease. So you have to first of all look at the characteristics. What are the characteristics that we can check out for? Let's say diabetes, we want to be modeled. We look at it. Maybe one of it could be the weight. We want to measure the weight of the person, the age of the person. So this is feature. This is one feature. This is another feature. Features, they also call attributes. Well, they also refer to as independent variables. Independent variables. Because the dependent variable, which is the target, Y, that we want to predict, we want to know if somebody is diabetic or not. That is the dependent variable. This dependent variable will be determined based on these independent variables. So weight, age, maybe family history, father history, maybe the father also suffer from diabetes, mother history. These are some very unique features that can actually help us identify if somebody might suffer from a particular disease. Number of time is the nature of his work. How many times he sit down in a day at work? See, number of sitting, hours of sitting. So these are called features. So you have to work with people in that area. Okay, what are the attributes we want? What are the attributes that are available? So usually people want to come up with as many features as possible because you don't know which feature will actually contribute to solving the problem. Now, so when you come up with these features, these are the feature or attribute or independent variable. Now we need samples for these features. Samples now. You now go to a particular person in the clinic. It could be a patient that's confirmed to have diabetes. You now ask him question. Hey, how many times do you sit down in the office in a day? Maybe this one says 6 hours. What's your weight? 80 kilogram. Age? 65. What's your father history? Your father has a history of diabetes? Yes. Your mother? No. Then, have you been diagnosed? This can be decided by the doctor. Sometimes the doctor already diagnosed this patient as having diabetes. So this is one. Positive. Then you go to another person in the clinic. The same question is sitting for 5 hours. He is 65 kg. Age is like 45. The father, no. Mother, no. Then the doctor already checked. They said, no, he's not diabetes. Because when you want to build a model like that, you need both negative and positive classes. So these are what we refer to as samples. So this is sample number one, the patient one. He may not be sick. He just in the hospital for anything or just random interview on the street. So we say this is a sample one, sample two, sample three. So the more sample you get, the better. So, but sometimes we run into a situation whereby we have this is 1, 2, 3, 4, 5. This is just only 5 features. But sometimes we have so many features. So, and you have up to 45 features. And for example, in material science, you have the weight of the material, the length. You have several characteristics you can check easily. You can just run automatic system that can check for you. For example, in permeability, oil and gas prediction, there are some gamma ray and some other ones that can easily be gotten from the system. However, the number of samples are often very few because at every depth, they have to take those measurements. So in that case, you might have a situation whereby the number of features are far more than the number of samples. This will lead to what we call cost of dimensionality. So I hope that clarifies for the questioner the difference between samples and number and features. So these are samples, and then these are the feature, the attributes that are common to those people or those material, or depending on what you are modeling, it could be a street. I want to model a street to know which street will suffer from flood. They have to come out with the characteristic that can determine if a street will suffer from flood. Do we have enough drainage system in that street? Drainage system could be one of the features, X1. Another thing is the environment slopey? Does the environment, is it slopey? That would be X2. You gather as many features as possible for that location. And now we now start filling in our samples. For street number 1, you put is it having drainage? Yes. Is it slopey? No. And the lies. Sample number 2, is it having drainage? No. Is it slopey? Yes. We have to fill it. So these are the number of samples down, and these are the number of features. Hopefully that clarifies. Thank you.
The sample from your explanation, the sample here is also taken as the observation in normal size. I don't know.
Yeah, that's what you call observation in social sciences and whatever. Yeah, yes. The observation.
Yes.
Yeah, these are the samples.
Okay.
Yeah.
Okay, because when we say sample is different in social sciences.
Okay.
The language sample is different.
Okay.
Okay, we have population, we have sample. Population will take care of the entire, people maybe in an area or the entire street. And the selected ones you want to examine will now be a sample. And you have to select in such a way that it has to be a reflection or representative of the population. Therefore, maybe the person is from social sciences, or the way we use the language sample is different. Thank you.
Okay, thank you very much. Yeah, for that. Yeah, I mentioned the data science, whatever you use in other area, we bring them down together here. We call it sample here. Okay? So it is in your at the lower level, at the micro level there, you can define what is a population you want to use, what is the subsample, the subpopulation. But finally, once you build your data, then we're gonna have the feature, and then we're gonna have the samples. You get the point?
Okay.
Yeah.
It's understood. No. Okay. Thank you. Yeah. My question now, number 1. Okay. I observed that I told you the other time, a couple of weeks ago, that there was a project I was trying to supervise. Okay, not a direct student per se, yeah. And from the analysis, I observed that when I conducted the feature selection, okay, and out of 20 samples, out of 28 features, the algorithms selected 2, okay, and selected 2. By the time I used the features to estimate the logistic model, okay, using logistic regression, I observed that those 2 features, okay, they have the highest level of significance. In other words, they are the best performing, features or explanative variables under logistic regression. Okay, but there are other features that were not actually, selected, that were significant, but their significant level were not, as high as that of the actual ones selected by the, by the algorithm. Okay. I think, I don't know, in machine learning, does machine learning only regard those features that were actually selected by the algorithm, and those ones that also perform were just, they were not considered as very important? Or we can combine everything together to get a clear, performance, okay, of the model. I don't know. Okay. This is my first question.
Okay, yeah. Let me answer that. Actually, it depends on if I get your point very clearly. You see, when you run the system first, if I remember the last time we actually discussed, when you run the system first, you run it on all the features. However, the performance were low, were not very encouraging. Yes. Then you started doing feature selection. And you use the very simple feature selection, which is the correlation-based feature selection, which is very popular and very simple, actually. And you are able to come up with, as you are reducing the feature, you selected those features with high correlation. Actually, correlation will be able to tell you that these features, they are likely going to have much effect on the output you are trying to target. So once you run in that way, it doesn't mean it's only saying that with these two features, you can successfully make your prediction. These are the ones that are having more effect on the system. However, as you add more features, because the number of samples are limited, this is what we call cost of dimensionality. Cost of dimensionality. So once you have, now we have X1 and X2, and they are getting you good results. However, maybe there are some features there that we think that these features are very important also. We should be able to use them. Okay, as you add them back, you increase it to 3. Note that your sample size, maybe is 28, if I'm not mistaken, is limited. The sample size is limited. It's fixed, by the way. So the more the number of features, then the more your system will suffer. The accuracy, the performance will start going down as you add more. So that is why sometimes we feel some features are good. However, based on the present reality of number of samples you are having, you cannot include them. You just need to let them go and go with the one that are performing for you. And the good news about having fewer number of features, like getting only 2, is that the next time you want to design your questionnaire, it means your questionnaire has to be designed with only 2 questions. Imagine having a questionnaire of 2 questions and somebody having like 30 questions. Which one do you think people will quickly answer? People will quickly answer you because you have only 2. Within 1 minute, they'll be done with you, and then you are happy, they are going to be happy. The moment you tell somebody, I want to have interview with you, okay, how many questions? Maybe 13. Oh, I'm sorry. Maybe you come next week. I'm very busy this week now. Because one of the challenges we face is when we gather data, if the number of features are many, it's not only that it may lead to cost of dimensionality, it's going to be very costly to get those data inside. So in short, what you are getting presently is a kind of information for you that, hey, you might need to go back, maybe in future research, try to see. And let me give an example here. There was a drilling operation. Usually people concentrate on some features. Engineers of experience, huge experience, they are like 3 they were concentrated on. But when we brought in machine learning, data mining, they were actually able to detect that if you pick one of these 3 features, they have been monitoring when they're drilling for oil. If you bring this one out and combine it with another one, X4, this X4 has never been used. They already thought it was not important. If you bring X1 and X4, we found out that they were able to get better drilling than what they were doing with the 3 before. And monitoring 3 variables is more difficult than monitoring only 2 variables. It was a shocker, a very huge shock to because these are experts and they have been doing it for a long time. And this is the advantage of bringing data science on the board. So there are a lot of things we are doing in the past. That's why I say sometimes we might need to shake tables. Shake tables means people are used to doing something in some way. Data science might say, no, you don't need 3. You need only 2 of these features. And go to anywhere, test it out. It will work for you. It is now up to human being because of human being like to stick to what they are doing before. Now we got something better, easier to collect 2 data than collecting 3. But sometimes also, once we are used to doing something in a particular way, we don't want to change it. So this is my understanding of the present situation. Okay?
Okay.
Go ahead. Your second.
Okay, thank you. Yeah. I observed something, I don't know, maybe from your previous classes, you made mention that the class category, okay, the class, right? The class, if we are to use it for regression, okay, the class should not be nominal, should be nominal variable. Okay, should have nominal value.
If you have to use it for regression?
Yes.
No. Maybe you must have mistaken what I said, because regression actually means predicting actual values. Actual values, okay? Let me clarify. Actual values is what you do, you predict. Maybe you have number like you want to predict what's going to be the annual profit for a particular company, maybe 28 billion, whatever. All those numbers, this is called regression problem. When the target is values, it's regression. However, when you want to do classification, I remember the clarification I made for you. Maybe that's actually got the confusion. When we discussed, I mentioned that when you have your data set for classification, sometimes we represent, this is the Y. We make it to be 1, 0, 1, 0. 1 means positive class, 0 means non-positive class. I say when you are using it in weaker environment, if you put it as 1 is 0, 1 is 0, weaker will take it that you want to do prediction. It will not treat this as a classification problem. So I say you need to make sure that your 1 is converted to yes and your 0 is converted to no, or YN. So in that case, weaker will be able to detect that, okay, this is a classification problem. It doesn't allow you to state your classification as 1010, which some packages, some other platforms, they don't have problem with it. But this is their own working. I think that was what I tried to classify. But regression has to be values. Okay.
Yes. Actually, I pick it like that. Okay. When in the classification, the class group is a case of a yes or no for the data. Okay. And successfully, I was able to do that. But when I went to estimate using, logistic regression, I changed it to 1 and 0. It rejected it in Weka, and then use this yes and no class, and it ran the something successfully.
Yeah, because logistic regression is a classification. Logistic regression is not regression. There's what we call regression. You know that. That one is for predicting values. The normal regression we have in statistics, okay? However, logistic regression was created from regression in order to be able to carry out classification. So when you see logistic regression, I can see people get confused on this issue. When you see regression, this is for predictive value. This is the classical regression we have in statistics. However, the classification aspect of regression has been created. We call it logistic regression. People used to think it is for regression. No, this logistic is the one that is doing the magic there, that is doing the work there. When it's actually a regression, but whatever value that comes out of the output, it gives it this logistic. This is the sign of logistic function. It's used the logistic function to convert it to either 0 or 1, which is going to be your output, which will be yes or no. So when you pick logistic regression, it's not actually solving regression problem. It is going to solve a classification problem. I hope that clarifies, Prof.
Okay, I think that was what actually happened, because when it's regression, when you just say regression, okay, I included logistic regression as part of what you refer to as regression. That was what happened.
Okay.
And one thing I noticed is that under the logistic regression in Weka, okay, we have only the coefficient and the odd ratio.
Okay, come again, Prof. What did you say, Doctor?
Under logistic regression.
Okay.
Okay. The output display, that is the result display by Weka, okay, contains coefficients and odd ratio.
Yeah.
Okay. Yes, that's what I found in Weka. But we can also obtain marginal effects. There's what we call marginal effects. Yeah. Also, we used to obtain, yes, we have marginal effects, because when we are interpreting, the marginal effects will give us probability interpretation. Okay.
Yeah.
But the odd ratio is not probability. Okay. The odd ratio is not probability. It's just a factor that if something changes by this, it will, this one will change by multiple of this or by a factor of this. But when you want to use the language probability, we go for marginal effects, which I cannot obtain in the Weka environment. I don't know whether you are familiar with this, but if we are using other statistical packages or econometric packages like Stata, we used to do that.
Yeah. Yeah, thank you for that, Prof. Yeah, it depends on the kind of analysis you want to do. When you finish your experiment, there are several. That's why you have several information being displayed for you, depending on the kind of analysis you want to do. So some people need the basic analysis of classification problem, which is you get the accuracy, you get the confusion matrix, and the area under the curve. These are classical classification performance measures. However, yes, depending on the particular area and your depth of the analysis you want to do, there are a lot of other values actually there. Actually, there are other values also that we can set to be shown, whereby you can also go deeper and then depending on the analysis that want to be carried out. Yeah, they are all possible actually. Yeah, that's why it comes with so many performance measures. So some of them might not be relevant to your own discussion, while to some other people that might be what they are looking for. And that's why I said, when we want to work in such a system, we look into the literature. What are they actually discussing? What are the most important performance measures? And then we can select them appropriately. Yeah, they are all possible, Prof. Okay?
Okay. Thank you, Prof. I think finally why I asked that question is that in the social sciences, if we are trying to look at relationship like that, we tend to, under the classification will tell us, we identify the features that can predict the response variable, that is the class, that these are the features that can, I think under feature selections or classification problem, it will identify something, but the direction of the relationship cannot be identified for us. That if this behave this way, we should expect this to behave this way. I don't know from the classification problem what other sense can we make out of the output, apart from focusing on the confusion matrix to tell us the accuracy, that this is it, true positive, false negative, and the like. Okay, are there other things you can make sense of from the results?
Okay.
Or do we have any reference that we can, maybe a text that we can explore to make more sense out of the results being displayed?
Okay. Yeah, thank you very much. It's clear. I got what you are trying to imply. Well, there are other ways you can actually deal with your classification problem. So, like I said, depend on the area. For example, when you build classification for medical, so what is most important to them is, hey, what is the positive? The first positive and the first negative, they are the big issue. You want to know which one is higher, which one is not higher. Then what you are looking at is you want to look at the trend. So the actual features, we know these are the features that are very important to get this thing done. However, what is the effect of this feature? Is it positive effect or negative effect? If I bring this one down, what's going to be? So this is where we talk more on explainable AI. That is, we want to be able to get deeper insights to the effect that each of these variables are actually contributing to the system. Yeah, correlation coefficient also is one area that actually it can also help us in this at a basic level. But there are other aspects of AI, like I said, we call it explainable AI, that can delve into more details in investigating the actual effect of these each of the features. Because sometimes we might actually have to investigate multiple feature effects together. Because 1 and 2, how are they making? What if I bring in third one? 1, 2, 3, A, B, C, A, C, D, C, and D. They might have different effects. In which case, we might have to share multicollinearity and also for others to be able to get better insight into those stuffs. Yeah, they are possible, but then we look at the discussion you have carried out before. Then from there, we can be able to provide necessary advice on what you can add to be able to achieve your aim.
Sir, I have some questions, sir.
Okay.
The question is that I'm working on particularly on some data here. I have 6 features.
Okay.
Then 60 samples.
50 samples.
60.
Okay, 60 samples. Okay, yeah, accessible. Yeah.
And one of these the features, some samples are missing. I have like 6 samples in one of the features. 6 samples are missing.
Okay.
So I'm now thinking, how can I deal with that missing data there?
Okay.
So that's the first question. Can I proceed the second one?
Okay. Yeah, we can answer that one. Okay. Quickly to answer that one, that is called missing value treatment. I want to believe if you search through our archive, we have videos that discuss how to treat missing value. But quickly, so you can just tell us that in missing value, there are many ways. The best way to treat missing value, we call it missing value treatment. Missing value treatment. Okay. Yeah. Okay. Yeah. So we call it missing value treatment. In brief, missing value treatment. The best way to treat missing value, one, is to go back to where you got the data and fill it in. You go back to the origin of the data and get the correct data. This is the best way to do, because we always want to use the best data possible. But we know that in reality, maybe the source of the data, even if you go there, they might not even know why the data is missing. There's nothing they can do. Then you go to the next step. The next step to achieve clean data as much as possible is for you, if the number of samples affected are not many, you can remove those samples. For example, out of 60 data, you are telling me data sample, you are telling me that only 6 has missing value. So if you remove 6, you're still going to have 54. Yeah, it's one option. So you can remove all those 6 samples with missing value. If there are only 6, you can remove them. You see? So that you can deal with 54. You know, you are dealing with original data from the source, where you got the data from. Now, sometimes removing sample is not an option because your data is so few. You don't want to remove anything. Then in that case, you have to treat it. Sometimes, if there's only one feature that affects all those 3, you remove the offending feature. Remove the feature. All the 6 missing value, they are under one feature. Then you can remove that feature, actually. So that instead of having 6 features, you can have only 5 features. That's another way to treat it. Another option is, number 4, is you don't remove any feature. You don't want to remove feature. You don't want to remove any sample. Okay. Then calculate the average of that feature in that column. What is the average? Find the average and use that average to replace the missing values. That is one way to deal with. You might need to calculate the average. You might want to use the mode, what's the common number there. So these are some of the ways that you can actually treat the missing value. That is, replace with mean, median, or mode, as the case may be. Use statistical value replacement. Another way we can then deal with it is you can actually use, this is more bigger issue, you can use another machine learning algorithm like k-nearest neighbor to predict the missing value. Predict the missing value. I mean, these are getting complicated actually. So from all these itemized options, like I said, you can refer back to our earlier video where we discuss some of this in details. So the best is to go back to where you got your data. If not possible, then remove those samples with problem. You have 54 left, that's still fine. 54 and 60, the difference is not much. But you don't want to remove, that's fine. Remove that feature that is causing the trouble. If all the missing values are having problem on one feature, other features are okay, you can get out that value. Yeah. If you don't want to do that, then replace with mean, median, or mode. So, or finally, you can use also what we call estimation method, predictive estimation, to solve the problem. I hope that clarifies your point. So you can go to a question 2.
Thank you, Prof. Sir. Thank you very much.
You're welcome.
Sir, on optimization, sir.
Okay.
Before I employ the optimize method to optimize the upper parameters, can I first tune the upper parameters? For example, now, maybe I want to use my C. Can I vary the value of my C before finally applying the optimize approach in order to know the effects of those values on the entire algorithm? Or I just apply the optimization method directly? Just first what's the...
Yeah, if I get your point clearly, what we are doing already is optimizing the upper parameters.
Values, sir. Thank you very much. Yes.
Yeah, if I get your point correctly, what you're already doing is you're already optimizing the hyperparameter by changing the value of C. Because the idea of the hyperparameter is for you to actually, let's say, if you are using support vector machine, you first of all change the kernel. I said the best one is to change the kernel. Look for the best kernel. The C is going to be at 1. The default value for C might be 1. Keep that one constant for now. Change your kernel. Try polynomial. Try Gaussian. Once you get the kernel that is better, then you now fix it. Maybe I got Gaussian to be the best. Then you go to C. C is the second thing you should change. Start changing your C. Could be 1, could be 100, could be... Then until you get this is called hyperparameter search or optimization, as the case may be. So what you are describing is already doing it, but it's always, if you are using support vector machine, it's good to do this one first, then you do this one first. And in one of our previous videos also, we've described how you can do grid search. You might actually need to do grid search, in which is, as you are changing kernel, you're also changing C, and then you are changing multiple things at the same time. But that one is going to be computationally complex, but it's also an option that can be used. Yeah.
Now, my question is also centered around features and then samples. So, like in a situation whereby the samples are few in one perspective, for example, I'm working on conversion of alkane to alkenes. Like from the search, there are several catalysts that can do this, but usually we change the feed. For example, we use maybe propane, hexane. So I want to ask, like, in this kind of, how do we deal with this kind of multi-feed? The catalysts are different, then the feed are different again. Is it possible to, in this way also?
No, well, if I get your point clearly, so now what you first of all need to come up with, what exactly do you want to do? This is number one. So okay,
Yeah.
I want to establish something. I want to determine if this is going to happen if I change this. Then you have to first of all come up with features. What are the characteristics? What are the characteristics? What are the features in that your area of interest. Are you talking of chemistry? Are you in chemistry or chemical?
Chemical engineering.
Okay, chemical.
But it's related to chemistry. Yeah.
Okay, yeah, because when I was hearing propane, I can still remember propane and the likes. Okay.
Yeah, just bring this example to
exactly.
clarify the question.
So we have to come up with features. What are the features? Sometimes the feature might be specific to that particular compound or material you are dealing with. Sometimes it could be maybe cross-platform features. Feature that is associated with something subject to the condition you subject it to. Maybe the temperature. Because you might have a particular compound. At certain temperature, you get some characteristics. How does it behave? At another temperature, it has another way of behaving. Another temperature, you have another way of behaving. So in that case, it depends on exactly, you have to streamline. That's how some people want to get as many features as possible. Okay, I want to study these compounds under certain temperature, under another temperature, under another temperature. Once you have it, in fact, what you never even intended might become a very hot predictive solution you might build. Because sometimes you might want to determine at what temperature does this particular material become unstable. Because based on those experiments, you notice that at some temperature, the behavior became abnormal. So at that point, it might be something that you want to actually investigate. So what you have to do is, first of all, come up with the features that are possible for you to extract. Then, out of these features, which ones are more difficult to estimate? For example, often not what we want to predict, the why, the output, they are the features that are very challenging to predict. For example, there's a feature you just run automatic weight. You want to calculate the weight. Put it on the weight scale, you can get it easily. There are a lot of attributes that you can easily get. But there is an attribute that you need to set it up in the lab for maybe 2 weeks before you get the result. We say these are very challenging to get. Instead of spending 2 weeks for one sample, can we get previous data and then use a predictive solution to estimate what we can get? And once we can train it properly, we may be able to establish what we want, actually. So I hope that is clarifying. Maybe you might have also want to get your data in an Excel file or whatever form, and then maybe we might have maybe personalized meeting depending on what you want. If anything is not clear, I can hopefully clarify it for you appropriately.
No. Okay, sir. No.
Now, you're always welcome. You can actually private chat me, and then we can discuss further if you need further clarification. Thank you very much. I think this is where we're going to call it a day. We still have other questions. Mohammed Balogun. Mala Mohammed Balogun.
Assalamu alaikum, sir.
Alaikum salam. How are you, brother?
Thank you very much, sir, for the section.
Welcome.
The question I have is somehow I would like love that you display the weaker, but let me just ask the question first. Okay. I'm working on a particular problem, so I use AutoWeaker to check whether it can actually the model that can work. So actually, when I use the automobile, it works. So, but I'm trying to build use that same this prediction from the AutoWeaker to see whether I can get it with the suggested algorithm there, but I'm not getting the result. So that is so I want to ask, is there a way I can go about that?
Well, thank you very much for the effort. I appreciate all your effort and then making a lot of inroad into using machine learning. Yeah, this so-called AutoWeaker is one of the it's spend a lot of time trying to do auto stuff. What I've come to note is sometimes some of the generated results are difficult to reproduce, which means something might be wrong somewhere. So, but then diligently, if there are algorithms that it's suggested, then you can pick up those algorithms that it's suggested that might work and then try to do it manually. This personally what I do and I recommend. So because sometimes the auto we run several times, at the end of the day, some of the suggestions might not be realistic. So perhaps something went wrong along the way of automation that they did. They keep providing new updates every time on timely basis. However, if they actually achieve a particular output, I want to believe it will be possible for you to reproduce within some error range, actually, plus or minus error range. However, if it is not as so, then I would advise that pick, like Oswald we say, keep it simple, depending on the area you are modeling. Keep it simple. Start with k-nearest neighbor. Try decision tree and then try support vector machine. So have you tried these three simple algorithms?
Yes, I've tried all those algorithms.
Okay.
But the accuracy, or let me say the R square they are giving me is very low compared to what I'm getting with the auto. Yes, auto is able to achieve up to like 98%.
Okay.
But all other ones I've tried to use a hyperparameter tuning, those things to try to optimize the result. Also, I use some feature selection to get it, but I've not. The highest I got is 77%.
Okay, it's fine. It's okay. Now, then, what you have to do with the auto is now the problem you're having which the method auto detected, you are not able to reproduce that exact result. Am I right?
Yes, yes.
Okay, then we may have to check something together. So unfortunately, because of our time now, I don't think we have the time. So you can get across to me. We can create a short time, and then I can look at what you have gotten and hopefully be able to make some suggestion for you on how to go about it. Okay?
Okay, thank you very much.
So Barakallah Fiik. So please get in touch with me. So within the week, inshallah, so we can get some things done.
Okay, sir. Thank you, sir.
Thank you for the efforts, and I wish you really all the best. I think it's a good day. It's a good time to call it a day at this point. Somebody. Okay, that's all for the day. Thank you all for listening, for the participation, and then I wish you all the best. Thank you very much. See you again next time. Thank you very much. Assalamu alaikum.
Wa alaikum salam.
Wa alaikum salam.
Yeah.